now is to say I am, or we are, 93% confident that this interval we found contains the true mean. So that the interval 2.19 to 2.55 contains the true mean GPA of students. So what's the probability that this doesn't contain the true mean? 7%. I like it. So you got a 7% chance of being wrong, which is better than normal for me. So I'm pretty happy about that. If you wanted to be more certain you're right, you would make this larger, which would change what here? If I wanted to be more confident, the z-score is going to get bigger. It's going to go further out, which is going to make your error bigger. Because if you want to be more sure, then that means you got to catch more stuff. I want you to see how that all connects together.
So the confidence directly relates to the z-score.
Totally, yeah, exactly. It's how you find the z-score is by matching up with how confident you want to be. Yep. So, but again, somebody would always invariably ask, well, I just want to be 100% sure. Then your interval would be negative infinity to infinity, theoretically. Right? So this is real life. I love it. This is math that goes along with real life. You're never going to be 100% confident about shit. But you can at least say, all right, what would it look like if I want to be 95% confident? All right, let me ask you a different question to kind of get us in the next direction we got to go. What if I want to stay 93% confident, but I want my error to decrease? What would have to change?
Sample size.
Beautiful. Sample size. I'd have to take a
Bigger sample.
larger sample size. So the next question is a feasibility question. Oh shit. You guys know what feasibility means? You're like, why don't you tell me? Do you know what it means, Jeff? So feasibility is it possible for us to do something? Do we have the resources to do something? So if I calculate how large of a sample I need to make the error something, and it comes out to be 18 million, that might be a little beyond me, right? I can't go look at 18 million people, right? So that's why I call it a feasibility study. So how large of a sample got us to have a 0.18 error? 92. So what if I wanted the error to be 0.1? But if I wanted the error to be 0.1, how large of a sample would I need to take? That's our next thing we're going to look at. That should make sense in the real world. I want to be able to control the error. I say we got to be within this much. So we have to have a way of figuring out, well, how large of a sample do I have to take to make sure that I am within that much. Still at 93% confidence since we got that z-score. Yes, ma'am.
The smaller the confidence level you want, the more room for error there is. Therefore, you need a large sample size.
So if you change too many things at once, it's a little hard to gauge how it's going to react. So if you want to be more confident about what you see, you can either increase the confidence level, or you can take a larger sample, right? Does that make sense?
And if you do both, you get even closer or not necessarily?
Yeah, if you do both at once, then you're even more sure about your answer.
So if you took a larger sample than your...
If I took a larger sample and at the same time I made it a 98% confidence interval, then I would be even more confident about what I see.
So then those numbers would be like just for instance, it'd be like 2.2 to 2.4, like the numbers inside.
Maybe. I like it. So two things. If I increase my sample size, what happens to if that's the only thing I change, what happens to my error? It gets smaller. Now, so when I say I'm more sure about what I see in my sample, does that make sense?
Yeah.
Why not? Why doesn't it make sense? The larger the sample gets, the more sure I am about its validity, so the less far out that I have to go. So then my confidence interval gets smaller. Is that cool? The larger my sample is, my error should go down. Does that statement make sense? The first day, we knew that statement was true. You guys came in knowing that. You know the larger sample is better. Why is it better? Because you know you're closer to the right answer. Closer, error, smaller, bam.
I'm not sure how relevant this is, but the bigger the sample size, does the standard deviation get smaller?
No, so remember, this guy won't change based on my sample because that is the population standard deviation. Right? But this, the bigger my sample gets, this will get smaller. Sure, I like it. All right, now, if I increase my confidence level, the interval actually gets bigger. And then I'm more sure about it because I'm catching more data. Maybe. So either I catch more data so I'm more certain that I caught the right one. Does that sentence make sense? Or I increase my sample size so I'm more sure about my estimate in the first place. And then I don't have to go up and down as much. Does that sentence make sense? Now please, dear God. That's all I want to say about that for right now. Don't worry too much yet about how, well, what if I do this and then not do that, and then make that one this way, and then, no, that's not, we don't even know this formula fully yet. Shit. Okay. So what if we wanted the error to be 0.1? So what part of this formula is the error? Yeah, this last part, right? So let me focus on, I'm going to make a little formula. The error is that. Is that cool? That is the error. Z times sigma over the square root of n. That's the error.
Will we ever be asked to find the error in that sense?
Of course. In fact, that's how we did this. We found the error. Right?
Right.
So here, what is it that I want to find, though, for this question? What do I want to find? What's the answer to this question going to be?
0.1?
No.
And we're basing it on the information we had from the previous, right? The previous question?
How large is sample?
Oh, okay, so we're not basing it on
Do I
the
need-
previous.
So we still know that this is true, right?
Right.
We still know that this is true. Cool. And I'm still using 93% confidence, so I still know that this
Okay,
is
so
true.
we're keeping
Is that cool?
Yeah.
I like it.
Square root of n is what
Multiple.
So what sucks about this equation then, if my answer is going to be how large the sample is supposed to be, what should really be on this side by itself? What do I want to have as an answer?
The standard time.
Yes, I want n to be here. This is stupid. This is, if I know all this shit, I can get the error easy.
Yeah.
So I have to solve this equation for n.
Oh, that's not-
It'll take a minute and try to do that. Algebra. Or draw duck. You know, I won't know. At least I see you write something. So one of those two things. Solve this for n,
Let's see what you have on the board, Mike.
or draw a duck. Say again? Probably, because that poor little n is stuck under a square root. You got to free him sometime.
So, on the z-score, does it matter if you put positive or negative? Should you put both?
No.
Plus or minus?
It's already built into the equation. That's why there's a plus and minus, because I want to go both ways.
So you're using 0.18? No, I don't understand.
What's happening?
For the z, what are we plugging in? The
Right
y?
now, we're not plugging in any numbers at all. We're solving
Oh,
that
we're just-
equation for n.
Okay,
Yeah,
I'm sorry.
that's all right. So it doesn't matter when you do the squaring, you know at some point you're going to have to square. So what I'm going to do, I'm going to do it at the end, just so I got less shit to worry about. The thing you're trying to solve for is on the bottom. That sucks. So if you had to solve the equation 7 equals 1 over x, you got to multiply by x to get it the hell out of there, right? And then you're dividing by 7. So one of the coolest things, now watch this, this is kind of funny. Is this true? Yes. Now watch what happens if I just switch those without even thinking. I'm just going to switch them and not even think. Is that true? Of course it's true. So I can just switch these. Bam. If you don't like that voodoo, what I'm actually doing is multiplying by radical n. Is that cool?
Work the hard way. We have the same answer.
Multiply by radical n. Right? Because you want to kill it down. I don't want the stupid thing I'm trying to solve for to be on the bottom. Stupid thing, come up. And then I don't want the stupid e over here. So I would divide by the e. It's going to end up down there. So because numbers act that way, and variables are numbers, I just don't know them yet, they have to do the same damn thing. I'm not saying you have to do this forever this way. I'm just saying that's an option because it's true. And then I can do what?
Square.
That's the last thing I got to do to get n by itself. So now I got my equation. N equals z sigma over e squared. So it's really easy to get lost in the weeds of solving an equation. But we know this is true. So any reorganization is also true. It has to be. That's the idea of an equation. Right? So I know this is true. So if I know this, this, and this, I can figure out how large my sample has to be to make that happen. So in this problem, I want to be within 0.1. And that's a magic word right there, within. Very often they're going to use that word, and that within means it's the error. Right? Within this much means that's how far off you want to be. So what is the value of e in that problem? Beautiful. And then we know that z is 1.81. We know that e is 0.1. We know that, what else we got? Sigma still is just sitting around being 0.976. Real quick, let me see if somebody, if I put 1.8 here for E, if I put 1.8, N is going to come out to be 90 frickin' 2, right? Do you guys see that? Because isn't that what we got? When N is 92, isn't this 0.18 error? So don't do that. So often people will do that. They'll take the error from the last problem and throw it in there. No. I want to change things. I want the error to be 0.1 instead. So now I just got to do Z times sigma divided by what you want the error to be now. All of that squared. Try that out, see what you get. I'll try it out too. Yes, ma'am.
Is there going to be a point in time where we use the S for our sample?
Yes, totally.
Okay.
Beautiful. In fact, that's the section I'm going to skip at first because it's going to use, it can't use z-scores then. The z-scores are built off of sigma. Does that kind of make sense? So there's going to be a slightly different distribution we have to use, and it sounds horrific. But it's not going to be near as bad as it sounds. I call it covering our ass for not knowing the real standard deviation. We have to use bigger scores than z-scores would be. Anybody got this answer yet?
312.
Yes, 312.07 blah 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 blah, right? So if you said the answer is 312, you're wrong. For a really technical reason, I've got to have at least this much to be within this much. So if you make this go down to 312, you're not within this much anymore. You're worse. So you always round this up. We've had something else earlier this semester do the same thing. N equals 313. So if I take 313 grades, my result will be within 0.1 of the true GPA.
So round up to the whole.
What happens?
Is that what you said?
So we got the answer
What happened?
312.07, and then you rounded up.
Yeah, 312.07.
You round up, because if you round
Round it,
up,
always round it up.
Okay, that's
Because they
right.
can't take 3 and 12.07 grades. You round up so you're even better than this. You want to be within
At
0.1.
least, yeah,
So we are definitely within because we made it even better.
better.
So no matter what, if I round it down, you're actually a little worse than this. That's no good. I see it's a real technical point, but oh well. You still got to do it the right way.
I don't get it.
So,
What happens?
I
What?
don't get what their point means.
because we're.
So when we took a sample of 92, how close did we end up within 0.18 of the real mean? Do you see that? Our error ended up being 0.18. So now, what would this have had to be in order for this to be 0.1? Hopefully it's obvious that that would have to be bigger, because I'm dividing by it so that it makes the answer smaller. So we sure enough, we come out with 313. So how do we do that? We forced this to be 0.1. And then we solved for n. That's how we did it. That's how equations work. What does this have to be if that? Well, I'm going to force you to be this, and I'm going to see what that has to be to make that happen. That's how equations work. That's how I talk about them when I teach equations. So like, give me the answer. When x is 7, what are you? Give me the answer. Yeah.
So when, in the work, will we know exactly when you want us to do that? Will it say to keep the same,
It'll be within the. It'll be like part A, and then part B
or
will
do
be
we always-
this.
that's what I'm saying,
So whatever
whenever
was true here,
do that.
except for the sample size, of course, because now you're trying to figure out what would it have to become. Yeah.
Because you could do it the other way, right?
What other way?
You could change the to 0.0005 and still, you always want us to increase the sample when we do that second problem.
If I said how big of a sample to make this 0.2, would it be bigger or smaller sample? Smaller. So it just depends on what you want the error to be. There's no. Normally we want the error to be better than this, but it's going to be based on what this.
I don't think you understand what I'm saying. My point is when you're asking that question, we're always going to use the sample size increase, not change the percentage to 99.9%.
Oh.
Does it make sense what I'm saying?
Yeah, I mean, this question has to be at a
Always
certain
at a-
level of significance. I'm sorry, a certain level of confidence, right?
Okay, that's all I'm asking.
Yeah.
Okay.
Because if I said this whole problem and I said I want to be 99% confident, then I would have put a different z-score here, right?
Right.
Yeah.
Right.
Okay.
No, I'm saying when it asks that, is it going to clarify that? Is it going to say it? Or if it says the percentage, we always do the percentage.
It'll say at 93%.
Perfect. That's all I was asking.
I mean, it's going to be the same as the first part.
Okay, that's
I'm not
all
going
I
to change it in the middle and like
It
catch
will
you.
clarify it.
Yeah. Okay. All right. Let's see. Yes, ma'am.
you said if we put .18 in there, it should equal 92, right?
Yeah, if you put 0.18,
I don't get 92.
let's see. Let's try that. So what would it look like? It would be 1.81 times 0.976 divided by 0.18 squared. What do you get?
96.318.
Rounded down to 0.18.
So we should round it up.
Oh yeah, all right. So it's got to be cool. Yeah, the 0.18. Remember was 0.184, whatever it was.
So should we round that up to be more accurate?
No, it's fine. You truly round that. Yeah. Okay. As a teacher, it's always weird to try to get you to realize what's important and what isn't. And you're all like, tell me what's important. Okay. Let's do one more example of this. Then we'll see. I think we'll probably take a break after that. And then I've got a handout that I haven't quite thrown enough stuff up here for you to do the handout yet. So we'll do a little bit more than the handout after the break. So let's do one more example of this.
So you said for these equations, the z-score is kind of irrelevant?
No, z-score is completely important. I mean, z-score controls how confident you end up being. So if you want to be more confident, you got to use a bigger z-score, so it forces you to go out further and catch more stuff. So the whole idea of a confidence interval is all about how much stuff you catch. So you guess where the fish is. I think it's about there. That's my X bar. It's my guess. That's my best guess. And then I throw out a net. And the more certain I want to be that I actually caught that little dude, the larger the net's going to be. Which means I'm going to go further out from the center, which means my z-scores would get bigger. Right? No fisherman has ever said that in his life, but does that visual make sense? I don't fish, I don't like fish, I don't eat fish. But the visual is a decent visual anyway. I love it. Yes?
So for the second part, you also have to write it out with how you're doing the first part, the answer.
Oh, no, you're just going to tell me it's going to be a sample size as the answer. Yeah. Okay. So let's say we take a sample of 38 fish to find an average length of what you got, Jeff? I don't know, Jeff. 16.92 centimeters. So far, so good, right? This is old news. We know. So let's say this is a certain kind of fish. All right, let's take a sample of 38 of those fish in this little pond. We know that the standard deviation of all this kind of fish, that's why it's a known thing, is what? Make a number up. There you go, Jeff. Good. There it is. All right, good. Obviously, I haven't actually gone and done this. So we're investigating this length. We took a sample of fish, and we want to see how long are these fish on average, right? We're going to make this interval, and then we can compare it to how long the fish normally is, and see if this little area that these ones are living in affects them, right? Maybe they're dumping some kind of weird waste in there, and they're mutating and getting larger, right? Or their nutrients are cut off so they're smaller. Do you guys understand what's happening? All right. And this is a sample, so I can't trust this number, but when I make the interval, I trust that interval more because it has information about how uncertain I am about what I see here. Okay. We will know that create the 98% confidence interval for the true mean length of the fish. All right. They gave us another evil number, but it actually eventually is going to become a nice number for us someday. Actually, later today.
Are we going to do z-score paper at some point? Or we just rip this out?
Please, yeah, take it off your test and you use it again. Yeah. Cool. That is your z-score chart. All right.
No, I was wondering if we were going to get another one.
Oh, God, no. Yeah. I don't want to use up all my blue ink. All right. Or my black ink. Don't say, well, do black and white. No. So take a minute. What am I going to find out from this that I need?
Like zero.
Sure. And then it's going to lead me to the z-score. I love it. So I know the formula I want to use is this one. And it's really, really easy to know when to use this formula. I'm going to ask you to make a confidence interval. You know, okay. It's got to be that plus or minus thing. So try to figure out, how do I know this is going to be normal enough? Yeah, n equals 38, greater than 30, check. So I know it's going to be normal enough. So to make the 98% confidence interval, that's what it would look like. So how do I find that z-score that I need? You're not looking at 0.02, right? No, it's not a z-score that you're looking up. You don't know the z-score yet. What percentage is in here?
1.
Yeah, 0, 1. 1%, 0.01. So what's the closest you can get to 0.01?
Negative 2.33.
0.01, not 0.001 or something like that.
2.33.
Yeah, the closer I get to 0.01 looks to be 0.0099. Do you guys see that? Let me stop there for a second. You guys understand? We've done this kind of thing before. So 0.01. I see 0.0104. I see 0.0102. That's better. But I see 0.0099. That's beautiful. That's only one away from what I want. Is everybody cool with that? Who's not? Anybody? Let me know if you're not cool with that. It's okay if you're not cool with that. If you disagree with me, that's one thing. But if you can't see what I'm talking about, that's another thing. If you disagree with me, you're wrong, so you'll live with it. All right. So guys, I appreciate that. That's 2.33 all day long. Whoa.
So that 0.01 is the z-score?
No, definitely not. That 0.01 tells me where that z-score is going to be. It's this area under it, right? So if I wanted 0.02 here, it would just push the z-score a little more in. My z-score would be smaller. Does that make sense? Let that make sense. I want the z-score that's 1% of the way in. That's 2.33. If I want the z-score that's 2% of the way in, that would be 2.05. Blah, 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 so forth. So already, we've done this before, right? I guess this is why I did that craziness on the practice test. Find the middle 98%, the z-scores that bound the middle 98%. That's exactly what we're doing. The middle whatever percent is the confidence interval.
You said you're using 2.3?
2.33. Because that's 0.0099. And that's as close as I can get to 0.01.
Okay. That's a negative z-score.
I don't care. Why don't I care? Because I'm mean. No, why don't I care?
Sorry.
Because the plus or minus is already there. It's not a big deal, but just realize all I really need is that number. So why am I getting the negative one? Because it's the quickest one to get. If you want to get the positive one, what would you look up?
1 minus
0.99.
that.
Because it would have 1% above it, so 99% below it. If you want to do it that way, beautiful. If you're worried about the negative, but all you want is the number, because the plus or minus is in there. So how do I build this formula? What do I put here? 16.92, that's your best guess, and then I'm going to go up and down from my best guess, modify it a little bit. And we just figured out how far up and down we want to go. 2.33, up and down. 2.33 steps. Yeah, so it'll be 2.08 divided by square root of 38, 11. Because that's how big a step is now for this group of 38. So this formula has a lot of old stuff in it. Stuff we should be familiar with now. Which is the way it works a lot. We just put it together to say something even more powerful now. We are going to be 98% certain. That's damn good. Only 2% chance I'm wrong. That's way better than normal for me. So what's the error you guys get? 1.83? 1.83, is that what you guys got?
I got 16.12.
Let me see, divided by square root of 38.
Oh, wait, we're not there yet.
Oh,
I skipped that.
0.78.
yeah, I get 0.786.
Yeah.
So 0.79.
Oh, sorry.
0.79? Stop there for a second. Alright, maybe. Is that cool, guys, so far? We're not done with this course. And now, you just gotta subtract that from this and add that to this. Right? So it's 16.92 minus 0.79? 13? I don't know.
17.71.
Yeah, this will be 17.71.
71.
Okay. How's that? Is that decent? All right, now, everybody cool with those numbers? So take a minute and try to write the conclusion. And yes, if you don't write the conclusion, you will lose points.
Okay, I have a question.
Yes, ma'am.
The point estimate is what, just those two numbers? And then
The
what-
point estimate is our best guess for what the average is, which will always be our sample mean.
Sample mean is always point estimate. So if I have a question that asks me, what is the point estimate for this problem?
Be careful. The point estimate is always what we see. So if I'm looking for percentages, the point estimate would be the percentage I see in my sample. Right, so if I'm trying to...
98 interval, right?
No. So if I want to make the 90% confidence interval for the percentage of gross one students who smoke, and you take a sample of 80 gross one students and you find that 42% of them smoke, that's your point estimate. It's what I see from my sample. That's the point estimate. Yes. Just your best guess based on what you saw. Aw. You poor guys. There's the work. There you go. Okay.
Do you want us to put the centimeters in put the centimeters?
What do you think?
Yeah.
Oh, hell yeah. Because you know what I'm going to do. If you don't, I'm going to say,